Okay, hi everyone. I was thinking about your upcoming test and wanted to give you a video on how you would do an equation to graph a rational equation where the numerator is bigger than the denominator as far as the degrees go. So this is number 8 from your chapter 2 review, or yeah, from your chapter 2 review. So we're just going to go ahead and go through this one together. If you feel good about it, don't worry about it. If you feel like you need to see it, this is your opportunity too. So all the steps that I ask you to follow in this problem are the same that we're used to seeing. First thing we want to do is to go ahead and rewrite our equation in factored form. Now, taking a look at the top, you're probably asking yourself, how the heck do you factor x cubed plus x squared minus 2x? And remember that we didn't talk about this too much, but the first thing you want to do when you factor is to go ahead and look for what we call a GCF. So as we see, each term in the numerator does have an x in them, so we can go ahead and factor an x out right away. If I do that, I'm left with an x squared plus an x minus a 2. And this is hopefully something that you can look at and say, hey, I know how to factor that. So now we can simplify both the top and the bottom into their fully factored form. Remember, for the top, you are going to keep that x there that's out in front that we factored out originally, but then we'll go ahead and add in the other two parentheses. So we'd have an x plus 2 and an x minus 1. And the top will become an x minus 3 and an x plus 1. So in this case, this will be my fully factored rational expression that we are going to use to try to help us graph. As far as domain goes, we're looking at where is the denominator not equal to 0. So in this case, I see that I will end up with a vertical asymptote at 3 and at -1. And these are going to be the two values that I go ahead and exclude from my domain. So my domain will be everything except these two numbers. Or in something like this. Again, that's where our denominator equals 0. As far as my horizontal asymptote goes, in this case, you're looking at the degrees of the top versus the degrees of the bottom. The degree of the top is, in fact, bigger than the degree of the bottom. What that tells me is that there is not going to be a horizontal asymptote. However, we could still determine what that asymptote or that end behavior asymptote looks like. And I am going to go ahead and run through this on the side for you. It's not something we spend a lot of time on, but I think it's kind of interesting to see. So to do this, we're going to go ahead and work with our original expression, our original equation, and set up our polynomial division. So I would have an x squared minus a 2x minus a 3. And we are going to divide this into x cubed plus an x squared minus a 2x. So right away, we're asking ourselves, okay, how many times does x squared go into x cubed? Well, that's going to be an x. So we will have x cubed minus a 2x squared minus a 3x. When we go to subtract, our first two terms cancel each other out. We're left with a 3x squared plus an x. So what this tells me is that if I was going to write my answer like we would for synthetic division, this would tell me that I would get an x plus a 3x squared plus x over, I guess you could technically do this further. However, what we would really recognize, we have an x. Let me keep going. So to get a 3x, we would get a plus 3. So we'd get a 3x squared minus a 6x minus a 9. We can go ahead and tack on a 0 there just to make it look a little bit nicer. You're left with a 7x minus a 9. So our remainder would be this 7x minus 9. But the thing that's actually more interesting to us is the x plus 3 that we have up top. This is going to be what my end behavior asymptote would be. So for example, I don't have a horizontal asymptote. However, my graph will follow the end behavior of y equals x plus 3. So we'll see what that looks like on the graph itself. It's actually kind of neat when you do see it all together. Everything else will follow just like it normally does. So our x-intercepts will be where our numerator is equal to 0. Be very, very careful here. My numerator has an x in the front along with the x plus 2 and the x minus 1. So I will have 3 x-intercepts in the top. I will have an x-intercept at 0, at -2, and at 1. That 0 is coming from that y equals x term that we have. And finally, for my y-intercept, we are plugging in 0. And we would get a 0 for the top over a -3. Well, hopefully we all know that 0 divided by any number is in fact just 0. So it looks like we'll have an ordered pair at 0, 0, which is kind of fun. Next up, we are going to go ahead and do our sign chart. I'll get this set up for you and then allow you the opportunity to try it on your own and then give you the answers. So we're going to go ahead and take our factored form of our equation, bringing it down. On our sign chart, we need our x-intercepts and our vertical asymptotes. I have an x-intercept at -2. I have a vertical asymptote at -1. I have an x-intercept at 0, an x-intercept at 1, and then that vertical asymptote at 3. So there are a whole lot of intervals going on here. However, we're going to do this the same way we do every other sign chart. So go ahead, take a minute or two, go ahead and do this, and then I will get your answers up on the board. Okay, so hopefully we got our sign chart to look just like mine. I do show you what numbers that I plugged in and what all the signs are, resulting in that final plus or minus that's right along the top. So now we want to go ahead and add all this information to the graph itself. First of all, we know that we have vertical asymptotes and this end behavior asymptote. So let's go ahead and get them graphed. So I have a vertical asymptote at -1. I have a horizontal, another vertical asymptote at 3. And if we go back, we have this end behavior asymptote at x plus 3. So we're going to go ahead and graph that line. It frankly is not that interesting. You got a normal y equals x line starting at -3. It will look something like this. It will intersect my vertical asymptote up here somewhere. So nothing honestly too interesting here. We can go ahead and change all these to our dotted lines. We got this was y equals x plus 3. This is a x equals 3 and an x equals -1. Getting our x-intercepts on here as well, and our y-intercept, we had a point at 0, 0. We have a point at 1, 0, and -2, 0. So it looks like my ordered pairs all look like this. We did have a y-intercept at 0 as well, but that's already covered by that point at the origin, so I do not need to write it again. If we are looking at our sign chart, we can go ahead and use that to determine what our graph looks like. So first of all, on the far right-hand side, on the far left-hand side, I am told that my graph is negative. Now, just like with our other asymptotes, we need to follow them. So what this means is that if the far left-hand portion of my graph is negative, I need to start down below that x-axis. So we are going to start down here somewhere. Just like normal, I need to follow that asymptote. So I do have this asymptote that would continue all the way down to -infinity. My graph is going to get close to this value here and then come up and hit that x-intercept at -2. This is going to be that red portion all the way on the left. These two lines that I got here, the asymptote and on my graph itself, will ultimately get really, really close to each other and follow each other to a T. then that second portion, so my orange portion that I got, my graph is positive. So I need to cross through my x-intercept at -2, and I'm going to come up and follow that vertical asymptote. Again, this is acting like a normal vertical asymptote. I need to get close to it as I go higher and higher. Then next up, on the right-hand side of that first vertical asymptote, so from -1 to 0, I am down below my x-axis. I'm going to come up and hit that x-intercept at 0. This will represent my yellow portion. Then my sign chart tells me that I am positive next. So I need to come up, cross through the x-axis, and then hit my next x-intercept. And then after 1 in that blue portion, my graph is negative. It will need to go down and then follow that vertical asymptote. So it will look like a parabola in the middle there. Finally, on that far right-hand side, my sign chart tells me that I am positive. Now, what kind of makes sense, it kind of works the same way our other ones, our other horizontal asymptotes and vertical asymptotes worked. This portion of the graph needs to be up above the x-axis. I need to follow both of those asymptotes. Remember, the blue dotted one will continue forever in this direction. And my vertical one will again continue positive forever. So this last piece, for it to follow those two asymptotes and to always be positive, it will kind of look like this weird V looking shape. So that's the only part that looks a little different than what we're used to seeing. But again, this is what happens when your numerator is bigger than your denominator, is that you get a graph that looks a little messed up. So hopefully this problem makes sense to you. I know it's a little weird because you haven't seen one like this, but I just thought it'd be good you'd see one prior to your test. Let me know if you have any questions as always, and I will see you guys later.